Let's do all the Open AI questions on LeetCode. Let's start with flood fill. So we're given an image represented by a grid of integers. It's going to be m by n. We're also given the start row, the start column, and a color. And we need to perform a flood fill. So let's understand what a flood fill is. So we'll start by changing the start pixel and change it to the target color. And after that, we need to go through all adjacent pixels. Adjacent is horizontally or vertically connected, so it's going to be up, left, down, and right. And if the adjacent pixel has the same color as the starting pixel, then we want to perform a flood fill. We repeat this process, checking the neighbors of the new adjacent cell that we started flood flowing from, and modify the color if it matches the original color as well, given at the start. And we keep on doing this process until there are no more adjacent cells left. Then we just return the image. So let's look at the sample input. We start with SR equals 1 and SC equals 1. And we change that color to 2. So that's this middle one over here. We know that the original color of the cell we started at is going to be 1. So that's what we need to compare the adjacent cells to. So we change this one to a 2. And now we flood fill. Well, what are the adjacent cells? We can go up, we can go right, we can go down, and we can go left. Going up, we check the color of that cell and compare it to the original, which is 1. So we can change that one to 2. And going left, we can also change that one to 2. We keep on doing this process for neighboring cells, and eventually we end up returning the image that looks like this. So this is pretty straightforward to implement. This is within the class of problems that I consider you kind of just do them, where you simulate the instructions that the problem gives you. To check the neighbors, we go up, down, left, and right. We can either use a stack or a queue to figure out the ordering of the neighbors to iterate over. We can also keep a visitor set to check cells we've already visited, so we never go back to a cell we've seen before. So let's try code this. We're going to start with the stack, with the original start row and start column. And we're also going to want to know the start color. After that, let's change the start color to the input color. And now we want to do some operations for cells in our stack. Let's pop the current one off. And let's check all adjacent cells. I like to do this by having a moves array where I keep track of all the cell coordinates with respect to the current position. So to go up, we want to go row -1, column stays the same. To go down, it'll be row +1 and column stays the same. To go left, we're going to go column -1. And to go right, we're going to go col +1. Let's also keep track of the max bounds. So we want max rows and max columns. Let's also keep track of the cells we've visited before. So let's have a visit set, and let's add the source into that. So that's going to be SR and SC. So now when we pop a cell off, we can check whether the next positions are in bounds. I like doing this by creating a new row. It's going to be cur0 plus move 0, and doing the same for columns. And now we can check whether the indexes are okay. If we can index into it, then we also want to make sure we haven't visited before. So now it's safe to index, and we haven't visited, so it might be a candidate for flood flow. So let's check that. If the color is the same as the start color, then we want to perform flood flow. And we do this by first changing the image, we're mutating it in place to the desired color. We then add this to the stack, and we also want to add this new coordinate into the visited set. Everything in a stack we eventually pop up, so we can consider that as visited. And that should be it. So then we want to return the original image. So let's make sure this works. Whoops. Start color. So it looks like I had a bit of a bug. Let's check out where it is. So I think I need a greater than or equals. Great. And let's submit this. Awesome. So let's consider the runtime complexity of this. In terms of the extra space, we have a stack and we have a visited, so that's going to be order of n. In the worst case, we might need to flood fill all the cells. And in terms of the time complexity, we visit each cell at least once. In terms of the time complexity, we visit each cell once in the worst case as well. So it's also going to be order n. Make sure to follow along for the rest of the Open AI playlist.